Tomorrow is the conference bowling tournament for all the 6A West Conference. So I will be out all day tomorrow. So I've already had to put ed puzzles together for tomorrow's algebra class. They got to watch an ed puzzle, which gives them the lesson as an ed puzzle. We're going to do it live and all kinds of fun. I had to do it for all my classes tomorrow because I'll be gone all day. But just that time of year. After the conference tournament, if anyone makes it to state, that's next week. Okay. So programming, I won't be here tomorrow. There's an ed puzzle for programming tomorrow. So yes, if you're in my 7th hour programming class, you'll have an ed puzzle to watch tomorrow that gives you the lesson. So yeah, out all day tomorrow because I got to be there in the morning. We got a coaches meeting. We start bowling at like 11. We'll be done till 4 or 5 o'clock in the afternoon. So all day thing. But that's okay. Almost to the end. If anyone makes it to state is next week on Tuesday in Fayetteville. So I don't know if we're going to state. Maybe done after tomorrow. Maybe. We'll see. I hope someone does really well and we advance to state. That'd be great. That means they had a great day. But possibility of not. We'll see where we end up. Anyways, hope you had a great Groundhog Day yesterday. Yeah, 6 more weeks of winter. Puxatawny fell. It was almost also my wife's birthday. She's a teacher. So my wife saw her shadow. So that's 6 more weeks of homework. That's how it works. Anyways, yeah, we didn't do much yesterday for her birthday because she's not feeling good. She got the same cough thing that I've had, and it's made her miserable. But let's see what algebra holds for us. I haven't even really dug in to see what algebra. Oh, I do remember what algebra is. Yes, this is a fun unit. This is a very different unit than what we have been looking at. So let me make sure I'm sharing this properly. As we're starting our matrix unit, matrices. So let's look at our grade screen here. Oh gosh, I didn't take the test. Yeah, I was so busy last week. I didn't take it. You should have turned in part 1 and part 2 of the test. I've been busy grading a bunch of your tests and I didn't do it yet. So I'll get mine turned in. But we are done with module 5. And hopefully that means you are done. And I've seen a lot of you turning in tests. I've been grading a bunch of, I still have more. I'm not finished. A bunch of you had it. And I graded them like last Thursday, Friday, because a bunch of you turned it in early last week. A lot of you turned it in this weekend. I have not got those graded yet. Like I said, bowling has had me. I had to run over to West today during my break in between classes because I had to get the credit card for lunch tomorrow and visit with the athletic director, get him to sign some things for me. So I have not had much time to do much of anything today other than just go through classes. But we are starting our matrix operations unit, module 5.5, and you'll see it's broken up into weeks. This is week 23. So we have to do everything that's in the week 23 folder. And then we've got the week 24 folder next week. The week 25 folder has a bunch of things in it. And the week 26 is just our last quiz. Now you'll notice some of these have like 4. Well, I broke this up into 2 different weeks. With there. I may end up moving that quiz into the last week after I look at it. But like we've got 3 things today. But here's the nice thing. They're short. This isn't like we need 3 hours to do this. We'll be able to go through all the lessons, and there's a lot of lessons because we do everything in that folder. When you look at week 23, do everything in the week 23 folder. Let's go back and say, what are you talking about, Mr. Brock? All right, I've closed the module 5 folder. If you have that open, you can close that if you're done with the test. And we have this matrix operation folder. So when I open it out, look, there's 4 weeks, the next 4 weeks. But we need to look at this, starting the matrix unit. All right, so we are using Khan Academy for the matrix unit because they have a lot of great information. It's like, why try to reinvent the wheel when this one rolls real nicely? So for the assessments in this unit, check your email, see if you sent a link. If you're not already a Khan Academy member, it sent you an email. If you are, that didn't include that, did it? I may have to fix that. Yeah, that is wrong. Let me Let me open up Khan Academy and wait a minute. Let me fix that real quick because it didn't include that in the link and it needed to. So course, that's the 5th hour link, as long as the 3rd hour link's right. But let me check and make sure my classes are right. That has the right link for you. WQ378 SD. Yes, that is correct. And I need to fix this one. I'll fix that when class is over. But I just want to make sure this link is correct for yours. If you have not joined my Khan Academy class through an email, here's a link that will take you to my class in Khan Academy. So just make sure when you get to Khan Academy that you are logged in. All right. And there are 2 assessments here. We got a quiz 1 and quiz 2, and we'll get to them as we go along. The important thing is make sure that you are logged in Khan Academy, and then it shows that you're part of my class. And if you need this link to join that, that's fine. I just want to make sure you have that. But let's look at what are we learning in week 23. So when I open up 23, don't freak out. There's 2 folders inside the week 23 folder. And when I open them, there's 6 things here. 3 of these are lessons, 3 of these are assignment. And it's not very long. So this isn't, like I said, it's not like 3 hours of work. So we're going to go through these together here, week 23. When you open it up, you just go through each thing. And it's a link. So let's start with the very first one, the Intro to Matrices. Good place to start. Intro to Matrices video. There's a link in here. So when you click on that, it should pop open another window. And I need to make sure I share this other window because it didn't automatically switch over for us. All right, so it will take you to Khan Academy to this video. So let's watch this video together as our introduction to matrices.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of 3. I guess we could call the 3 movies combined The Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So, for example, this right over here, if I have 1, 0, -7, pi, 5, and, I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has 2 rows, and it has three columns. And because it has 2 rows and 3 columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has 2 rows. So you see the 2 rows right over there, and they're telling you that it has 3 columns. You see the 3 columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has 1 row, 1 column. I could have a matrix like this, 3, 7, and 17. What is this? Well, this has 1 row. This is the 1 row we see here, and it has 3 columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has 3 rows. So it's 3 rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix, 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program or you're trying to do an economic simulation or a probability simulation to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
All right, so that is giving us an introduction to what a matrix is. It's just an array of numbers. So after you finish that, you can go back to the buzz screen where we were. We're done with that, so we'll go back here. And look, it's got a little check mark there. We're done with the Intro to Matrices video. So now let's have the Intro to Matrices lesson, and it very much just reinforces what we learned right here. But let's look at the Intro to Matrices lesson. So if we click on that.
Did she give any like specific office text, like from
And
1 to 1?
you know, squeeze over in the side of the scene. There's a little arrow right here. If you click that, it'll open this up and make it the full screen. So over here, it just shows you there's the video we just watched, Intro to Matrices. Now here's the lesson. But we can close that, and that makes it easier to see the screen. A matrix is an arrangement of numbers in rows and columns. So let's see. A matrix is a rectangular arrangement of numbers in the rows and columns. For example, matrix A has 2 rows and 3 columns. So we see this. So here's A. We name a matrix equals, and here is the data that's included in that matrix. And there are 3 columns. Columns are up and down. Like you see a column on a building, it goes up and down. That's a column. Rows go horizontally. So this has 2 rows and 3 columns. And the dimensions of the matrix tells its size. It tells the number of rows and columns in that order. So since this has 2 rows and 3 columns, this is called a 2 by 3 matrix. 2 by 3. Rows first. We'll see how many rows there are first. In contrast, if we look at matrix B right here, it has 3 rows and 2 columns. So it's a 3 by 2. 3 by 2. So remember, it's always rows, then columns. Rows, then columns. The smaller word followed by the bigger word. Rows, then columns. So when you do this lesson, you can go back and do this on your own, and this gives you some practice right here. Check your understanding. Here's the practice problems built in. What are the dimensions of matrix D? All right, I'll open up the chat. Tell me what are the dimensions of matrix D right here on the screen. What by what? 4 by 3. I've seen a lot of people jumping in with 4 by 3. There are 1, 2, 3, 4 rows. There are 1, 2, 3 columns. Check mark, green check mark. Great job. All right, what about matrix E? What is the dimensions? What are the dimensions? All right, you guys are right on top of this. Not going to be hard, right? Check. Absolutely. What about matrix F? All right, Ava. Yeah, 3 rows, 1 column. All right, now let's talk about the actual elements inside. So a matrix element is simply its entry. An element is identified by naming the row and column in which it appears. So let's look at matrix G right here. So G is a 3 by 3, 3 rows, 3 columns. It has these 9 numbers in there. And if we talk about element 2, 1, 2, comma 1, that means second row, because the row is first column. That's what number 18 is. G21 is 18. Second row, first column. So don't make that hard. It is just that easy. Rows, columns. So let's see how we do with that. Which number is A? Here's A. 1, 3. 1, comma 3. Which number is that? One comma 3. I'm seeing some different answers. That's why we do these practice problems. 1 comma 3. I've only got 3 people that's even taken a guess so far. Oh, there's a few more now. More folks coming in. So remember, what comes first, rows or columns? Row, column. Row, column. Row 1, column 3. Where's row 1? 2, -4, 8. That's row 1. Where's column 3? Well, that's the 8, -5, 2. The element, the number that's in 1, 3 is the 8. First row, 1, 2, third column, right there. Check. Yes, that's correct. All right, let's try this. B21. Here, I'm going to do it this way. I'm going to get where I can write on it a little bit. B21. So people, I see a lot of 4.6s. So B2, that means, let's see, first row, second row. All right, that's the second row. And I want the first column. So the one that meets the requirements there. Oh, so I can change colors. Nice. 4.6. Absolutely should be 4.6. So we type that in, 4.6. We check. Green check mark. Oh, I like this question. This is turns it around. Okay. So I can show this. So here are 4 matrices. Matrix C is a 2 by 3 matrix with C1, comma 2 is equal to 6. Which one of these could be matrix C? There's people saying C. The 2 by 3 matrix. So if we look at a 2 by 3 matrix, we can rule out 2 of these right away, right? Because 2 of these are 3 by 2 matrices. A and B are both 3 by 2s, so they are not 2 by 3s. So we got to pay attention to 2 by 3s. And we want 1, comma 2. So first row and the second column, that has to be C then. C is 6. All right, great job. That's the last of those practice problems. So when we go back, we've now completed both of these. Now we have 2 assignments. And these assignments are very simple. But I want you to read the directions when we go here. Take a screenshot of your score at the end of the Khan Academy assignment. and then scroll down to the bottom of this page and paste your screenshot. So you got to scroll down here and click there, and that's where we're going to paste our screenshot. All right, so let's go back up here and click on the link to see the assignment. So Khan Academy, and it'll do different problems for everybody. It randomly will pull problems. So whatever I have on the screen is not what you're going to have. You'll have something similar. Again, we can close this little tab so we can see more of the screen. There it is. Remember, make sure you're logged in. See, mine says Mr. Brock up at the corner. Make sure you're logged in on here, and it'll help keep track of what you do as well, in case you forget the screenshot. Ready to practice. Here are 4 questions. You click down in the bottom. Let's go. First question, what are the dimensions of this matrix? These are all about matrix dimensions. This whole first assignment is what are the dimensions? So rows times column. 1, 2, 3, 4. There's 5 rows and there's 1 column. And after you put that in and hit check, good work. Keep going. So you got 1 right. Down at the bottom, it'll show you your 4 problems and how many are correct. I got a check mark. Next question. What are the dimensions of this matrix? How many rows? 1 row. How many columns? 1, 2, 3, 4. 4 columns. Check. Oh, and if you're confused, like you got it wrong, you wasn't sure, you can click on see how we answered the question. And when I click on that, it gives you a detailed answer. First, the first dimension is the number of rows. There's only 1 row. The second dimension is the number of columns. There's 4 columns. So the dimensions are 1 by 4. So if you get one wrong, you can click on see how we answered the question, and it'll show you what you messed up on, right? Next question. What are the dimensions of this matrix? Well, I see 2 rows. I see 1, 2, 3, 4, 5 columns. Check. Okay. I've got 3 check marks at the bottom of the screen. This matrix, 1, 2, 3, 4 rows. I see 2 columns. Show summary. Now, this is what I want to screenshot. I'm going to take a screenshot of this right here. There's my screenshot. So they got 4 out of 4 correct. I go back here to Buzz, and I paste that in Buzz. So I got 4 out of 4. Submit. Done with that assignment. Let's look at the second assignment. Matrix elements. Again, you got to go down and screenshot, just like the other one. Take a screenshot. Let's do this one. All right. It always has this little half tab open, which I always close that. Okay, it's asking, what is A4, 1? The rows are first, 1, 2, 3, 4. So I want this bottom row. First column. So A41 is 6. 4th row, first column. Good work. Next question. A51. 1, 2, 3, 4, 5. That's the bottom row. First element there. First column. 3, 4. 1, 2, 3. That's the middle row. 4th column is the last column, so that should be a 0. That's it. I take a screenshot. My screenshot shows for matrix elements. See, for matrix elements, I got 4 out of 4. Got my name up in the corner. I go back down here, paste in my screenshot, turn it in, submit my work. All right, so far matrices seem pretty easy, right? Just counting. Don't make them difficult. Matrices are not difficult. And just go through these, and you can go through these lessons as many times as you want if you got confused by something. All right, so we're done with the first folder for this week. So introduction to matrices, we're done with that first folder. We have another folder this week. We're still in week 23. You want to make sure you finish everything in week 23 and see how quick this is going. Representing linear systems with matrices. All right, let me close that other matrix thing. Let's take a look. This is not an assignment. This is teaching us something new. I'm not sure if this is a video or if this is a lesson. Let me close that. Okay, this is just a lesson. It's not a video. Okay, we're going to learn how a system of equations can be represented by augmented matrices. So a matrix is a rectangular arrangement of rows and columns. We knew that. 2 rows, 3 columns. So that's a review. Matrices can be used to solve systems of equations. But the first thing you got to know is, how do I write a system of equations as a matrix? All right, so follow along here. If we have a system of equations, that means we have at least 2 different equations with 2 different variables, right? At least 2. Let me make this a little bigger. Oh, good. I've already got it a little bigger. I got it 120. Let's do it 150%. Here we go. System of equations. So if we have 2x plus 5y equals 10 and 3x plus 4y equals 24, we can write this as a matrix. We take the x and the y and we get rid of them, and we just use the coefficients. 2, 5, 10, 3, 4, 24. Now, do you see where we got the numbers from? The x is the first column. 2 and 3, that's the coefficient of the x's. 2 and 3, that's the first column. The second column is the y's. So I just take the coefficients. I've got a 5y, so I take a 5, and a 4y, I take a 4. And this last column is the constants. It's the numbers that the system equals. It's a 10 and a 24. So this augmented matrix represents this systems of equations. Each row represents an equation, like this is equation 1, 2, 5, and 10, because we've got 2x plus 5y equals 10. And then each column represents either one of the variables or the numbers at the end. All right, let's scroll down. In this way, we can see that augmented matrices are a shorthand way of writing systems of equations. So it makes it unnecessary to write down the x, y, and the equal. We don't. It's still there. We know what it represents, but we don't have to use the x, y, and the equal. All right, here's our check our understanding. If we have this matrix, we have 2 matrices to choose from. If we have these 2 equations, 2x plus 3y equals 8 and 5x plus 2y equals 2, which one of these matrices, A or B, represents that systems of equations? A or B?
Hey, did you think at all about Wesleyan?
Okay, got a couple folks have answered. Which one represents that systems of equation? All right, everybody's coming up with the same answer. See if you're right. B, because 2, 3, and 8 are the first one. 2, 3, and 8. I see 5, 2, and 2. I see 5, 2, and 2. If I check out A, 5, 2, and 2, that says 2, 5, and 2. That's got 5 with the y instead of the x. The 5 is part of the x. Correct. All right, let's try this now. Now we have to write the matrix. It's given us 2 equations, and we have to write the matrix. So our first equation is 7x, but we don't put the x. 4y, but we don't put the y, equals 3, and we don't put the equals. 7, 4, 3. Second row would be the second equation. 6, 3, and 5. And we got the green check mark. That is correct. All right, let's look at another example. This is a little more complicated. We have 3 equations, and we have 3 variables. We have an x, a y, and a z. But notice some of the equations don't have all 3 variables. So we can still write this as an augmented matrix. So let's rewrite the system to show the coefficients clearly here.
This is the starting of a
If a variable term is not written in an equation, that means it has a coefficient of 0. There's still a z. There's still a z up here, but it's 0 z's. 3 x's, negative 2 y's, 0 z's equal 4. So if we add those into the equation, it all balances out to where now we have 3 x's, 3 y's, 3 z's. It's just some of them have a coefficient of 0. So we can write as 3, the x column, the first column is 3, 1, and negative 4. We go back and look at those original equations, 3x, 1x, negative 4x. There is an x in all 3 of those. So our x column is 3, 1, and negative 4. Our y column, well, if we go back and look at the originals, we had negative 2y in the first one. I don't see a y on the second one. There must be 0 y's in that equation. And the last one has a negative y. So if we've got negative 2y, 0 y's, and negative y, that's negative 2, 0, and negative 1. And the z's, there was no z in the first one, but we have 5 and 3. So we've got 0, 5, and 3. And then, of course, it equals 4, negative 3, and 0, 4, negative 3, and 0 go in that last column.
Yeah.
So don't let that trip you up. If you don't see a y or an x or a z, that means there's 0 of them. So you just put a 0 into the augmented matrix. So notice how each column still corresponds to a variable. This is still all the x's, still all the y's, still all the z's. We don't mix them in a column. We don't put an x and a y in the same column. So before converting a system to an augmented matrix, make sure the variables appear in the same order. Because maybe they'll put 2x plus 3y and the next equation has 4y minus 2x. Put them in the same order because the x's have to stay in the x column. All right, which matrix represents this system right here? We got A, we got B. Don't let it fool you. We got 3y minus 2x plus w plus 5z. We got w plus 2y minus 4z. A or B? Seeing a few people.
Like, I feel it for you. Like, oh my God. That would make
Just
me
a few starting out here. A or B? Wait, oh, I got A's and B's now. I've got some people saying B, some people saying A. The tide has switched.
That was like AA rock.
So what's the difference in these two matrices? They both have a 5, 10. They both have a negative 4, 5. They both have a 2, 1. Oh, it's the 1 and the 0 or the 0 and the 1. That's the only difference. So which is it? 1 and 0 or 0 and 1? Well, let's see. That's in the second equation. The 2 and the negative 4 go with the YZ. So what the difference is this W. So we have to make sure the 1W goes in the same column as the 3W. Whatever column the W is has to be consistent. So if you see 3 and 1, this one has 3 and 0. The X is a negative 2, so that's the second column. So yes, the W has to go with the W. It is going to be A. So we had some starting out thinking B, and then we took another look at it and went, wait a minute. Wait just a cotton picking minute here. Yeah, W goes with W. Good catch. Glad you all changed there. Correct.
Let's turn those cameras on.
Great job. All right, now we get a right one. So tell me the numbers that go in the first row, just the first row numbers for this system of equations.
Okay, stop, please. Thank you. Turn your cameras on. Hold on to that.
Which four numbers go in the first row?
Joanna. Okay, Vance, I need you to meet
All right.
Annabelle.
Yeah, the first thing we have to do is compare them, right, to know that we've got all the variables.
I saw it. Thank you.
Got to look at both of them and say, okay, yep, okay, we're good. So I see that people are saying -1, 1, -2, and 12. I saw that. The first three people said that.
I see it like that.
Okay, -1 would be negative A.
Closing in.
1 would be plus B. -2 would be -2C. 12. Okay, that looks good. I agree. So what about the second row? What four numbers are we putting in the second row?
If teachers aren't
Abe already had it typed. She was just ready to hit enter as soon as I asked. Huh?
Okay, some of you I still see doing work on Sunday.
I'm seeing the same answer over and over again. Think you guys are getting it figured out? Let's see what answer you're putting in there. You're putting 3, 1, 0, and -8. All right, let's see how we did. We got a 0 there because this is the C column, -2 and 0, and this is just a C in the first one. Great job. See, is there another one? Oh, challenge problems. All right, it get harder. Oh, which system is represented by this matrix?
All right.
There, I got it all on the screen. Okay. So we have this matrix. And is this matrix representing A or does it represent B? Hmm.
Because we're missing work, we are listing our missing work, not some. or-
B. I see a lot of B's. And when I look, I got to compare 5x plus 2y minus equals 0, 5x plus. Okay, so the third line is the same in both of these. 4x plus y plus equals 2, 4x plus y plus equals 2. The second line is the same in both these. The only difference is the first line. -3x minus 5y equals 8, or -3y minus 5z equals 8. And since 5 is in the, this is x, y, z, according to these other equations, x, y, z,
Well, why not?
should be B. Good job. You guys are paying attention to the details. Let's check. And we got that correct. Oh, no, this one's got 4 of them, so I need to take a picture of this one. I knew one of these I was going to have to do that. Which matrix represents this system? So let me make this smaller.
Hold it
Put
on the fan, I'm not sure.
it over here.
Any other questions about this week? We need to make
There
sure
we go.
that-
Got it all on the screen at the same
Great.
time. So we've got the matrix over here, all 4 choices, and we have the equations on the right. Is that A, B, C, or D that represents that system of equations?
Does that work in this century?
This is a challenge problem, guys. Remember, it said we got to have them in the same order, and these are not in the same order. So it may fool you. It is a 2x3 matrix. That's consistent all the way down. I do see a 2x3 matrix everywhere, but which 2x3 matrix is it going to be? This is a good challenge problem right here. Daniel's giving a guess, but everybody else still looking, trying to figure out for sure what they want there. Abigail's tossed her hat into the ring here.
Joanna, what are you referencing on that? You said you already talked about it. When you said you already talked to me about the Berkeley, Arkansas thing, you went,
All right, this was a good one.
oh,
Got a C and B's. That's been the choices right here. Both of these. No one's thought A. No one's thought D.
they told me they never logged in, so.
See, if we look at A, they just took the numbers as they are. 3, 2, 12. 3, 2, 12. Negative 8, 2, 15. Negative 8, 2, 15. That's what A did. No one believes it's that. And you're probably right. This one's quite different. Let's explore this just a little bit then. I've taken those two equations. I'll turn my light on. Oh, my light is on. All right. And I've written both of them down. And we want to put them in the same order. So what do we have? We have an X and a Y and equals a constant. We need them both in the same order. So here we've got 3x plus 2 equals 12y. The y is on the wrong side and the 2 is on the wrong side. So let's subtract 2. 3x equals 12y minus 2. Now we need to move the y to this side, so we've got to subtract it from both sides, which means we have 3x minus 12y equals negative 2. X, Y, and the constant. So these are in order. So this is a 3, negative 12, and a negative 2. That would be our first row because this was the first equation. Let's look at the second. Got negative 8y, but the x is over here. Move the x to the other side. So subtract 2x minus 8y equals 15. X, Y, 15. Okay, so this one would be negative 2, negative 8, 15. So we're looking for the matrix that has 3, negative 2, negative 12, negative 8, negative 2, 15. Let's see which that would be. Looks like C. Is it? Yeah. C
I want to know your mood.
is correct.
What are you reading?
See, we sit there and we say, okay, well, the y should be on this side. But remember, if we move the y to this side, that makes it a minus 12. See, some of you just said x, y, and 2. 3, 12, and 2. But when we move those to the other side, we have to do it mathematically. We got to subtract 2 from both sides. We got to subtract 12y from both sides. So make sure you're not just looking at the numbers. You have to do the math. You have to legally move it to the other side. So that's how we got onto this, is moving the 2 over there, subtracting 2, moving the 12y over here is subtracting 12y. So it changed the signs of both of those. And same thing for the x over here. It changed the sign of the x, moving it to the other side. Good try, but that's why they have these challenge problems, so we can figure that out here before we're trying to get the 4 points. And that's the end of that. So let's put that back down a bit. Okay, we've gone through this lesson now. So if we go back here, the only thing left is this now. It didn't give us the little green check mark there, but that's okay. It's not an assignment. Screenshot down here. So here's the assignment. We'll close our little half page there. All right. Oh, apparently I already did one. I've already got a check mark at the bottom. I already started this. I don't know when, but I started this at some point. All right. And I got the first one right, so we're good. Which of the following matrices represents this system? And we got 4 choices there. So we got 9x plus 5z minus t equals 10. We got 12x plus 3y plus 2z equals, minus 10t equals 4. So we got an x, y, z, t, x, z, t. So that means there's no y in the first one. So I need a 0 with the y. Well, that has to be A. That's the only one that has a 0 with the y. -1t, -10t, -1, -1, okay. Those are all lined up okay, but the 0 should be with the y because there's no y up there, and the y is the 3. Check.
All right, so go over there.
Yay, let's go to number 3. Which of the following is an augmented matrix? Oh, write the following system. I'm sorry. Write the following as an augmented matrix. X, Y, 15, X, Y, 4. Okay, so there's no missing terms. So we've got a 4 and a 7 and a 15 and a 6 and a -8 and a 4. Straight across. There's no rearranging needed on that one. Our last one, which of the following represents this system? X, Y, Z, T, X, Y, T. Okay, so the X is 4 and -10. They all have 4 and -10 in the X. The Y is 4 and -1. They all have 4 and -1. The Z is -3 and 0. There's no Z down here. That's wrong. This one is -3 and 0. That's wrong. That's wrong. All right, so it has to be B. Summary. Screenshot. All right, representing linear systems with matrices. My screenshot is ready. Paste. 4 out of 4. Now here's the nice thing. Maybe I messed something up. I only got 2 out of 4. It's like, oh, I messed it up. Well, I can click right back here. I'm going to close that. I can click right back here and I can try it again if I want to. I can do it as many times as I want to. Every time I click, it'll go to Khan Academy and open up another attempt. So you're not limited on how many times you try before. Don't screenshot it. You get 1 out of 4. Don't screenshot it. Go back and redo it. Well, see, are you ready? 4 new questions. So yeah, wait till you get a score you want before you copy and paste it in here. If you don't want that score, just go redo it. They don't take that long. All right, submit my work. And that's the end. The next is week 24, so I don't have to do that folder. We've done everything in this folder. We've done everything in this folder. We're done. If I want to double check, I can go to the grade screen. And it shows, look, I've turned something in for all 3 of these due dates. Turn something in, turn something in, turn something in. So I am done. Next week I'll have 2 to do. And then a couple there. So I've done all 3 of those. So don't let the matrices intimidate you because it looks a little different. It's still relatively very simple there. We went through the dimensions, how to know the dimensions. It's rows by columns. We went on how to talk about any one element. 2, 1 would be the second row, the first column. So it's whatever numbers in that spot there, 2, 1. And representing linear systems with matrices. Match the X column, the Y column, the Z column, what all variables you got. Just make sure all the numbers match up correctly to the equations it's representing. And you're good to go. So yes, matrices are not complicated. You just got to pay attention to the details. Because that's what we saw on like some of those that it's like a 0 or a -2 or a 12 or -12 or, what is it? Just pay attention to the details. And of course, working it out, if it's in the wrong order, make sure you're legally moving the variable from one side to the other side. Legally. So, but that's it. The nice thing I love about the matrices is that, well, number one, if I mess it up, I can go back and just restart it. I just close that window, go back to Buzz, click on it, it'll open up a brand new window, and after I do those 4, if I don't like it, I can just do those 4 again. And it'll keep it for me. Make sure you're logged in the Khan Academy though. So that way it'll keep track of it for you on where you're at, and won't have you redoing a bunch of stuff you've already done. But yeah, if you don't like it, do it again. And if I don't remember how to do it, I can click and there's the little lesson or video in Khan Academy that'll teach it all to me again. And what's it take? 5 minutes per lesson? The video was like 4 minutes. It doesn't take very long. So Lots of little practice built in there that you can check to see if you're right. Get the little green check mark. Yep, that one's right. And the assignments are just 4 problems, and they're pretty quick. So I really like this unit. We'll be doing this for the next 4 weeks before we move on to our next item. So matrices. Have fun with it, guys. Learn something new about matrices. But that's all I got for you this week. It's a little shorter this week. That's not a bad thing, is it? You've got time to perhaps get most all of this done before 4th hour. So if you have a 4th hour, I think you can finish before you get there. But get this done. Don't wait till late in the week. It is an A day Friday this week. So we will have class on Wednesday and Friday. So if your grade's below 70%, this may be a good week for you to get caught up because the matrices will be pretty quick this week. It won't bog you down too much. So if you need help with anything, I'll be here Wednesday. I'll be here Friday. If your grade's too low at the moment, you'll be here Wednesday. You'll be here Friday. So either way, I'll either see you later this week or next Monday. Yes, 2 Mondays from now we don't have school, but next Monday we do. All right, guys. Have a good afternoon. Go work on this, and I'll hang around here a little bit if anyone is stuck or need help with it.